My name is Alfredo Terrazas. Today's date is 2/27/2021, and this is my submission for CIRC02 Attempt A. In this attempt, we're supposed to be testing out our own animations, trying to work with the code on our own, see if we can figure something out, something different. What I went ahead and did is I reused a pattern from Attempt B, the in and out, for the green LEDs. That stays the same, but I added two red LEDs that will be just on and off, nothing flashy about them, but all of the LEDs will only turn on when a button press is registered as an input, and will turn off when there is no input from the button press. Essentially, they only turn on when the button is pressed. Starting with the sketch or source code, we have the identifiers, the variable names for the button pin, which is going to be 10. We have the LED pins, which are going to be the green pins, 2 through 9. We have red LED number 1, which is on number 11, and red LED number 2, which is on number 12. And for the button state, we're going to have an integer of 0 to set a variable for reading the push button status. Therefore, the code will know when the button is pressed. Starting with the void setup, we're going to go ahead and just set the same for the LED pins. We're gonna set them up from 2 to 9 in a single line of code, so I don't have to write them out each individually to save space and typing space. To save typing space, we have the pin mode for the LED pins, which is gonna be for the output, and we're gonna have an input for the button pin for the number 10. And that's gonna be as far as the setup goes, for both to initialize the LED pins as output and the push button as input. Moving over to the void loop, we've got the reading for the button state. This button state is going to read the digital read on the button pin, which is number 10. We assigned it at the beginning. And then if the button is pressed, it's going to set the button state to high. When the button state is set to high, the LEDs will turn on. And right here we have the codes for the LEDs that will be turning on. LED 1 and 2, red LED 1 and 2 will simply turn on. And here we have the exact same code for the on and off, which again is going to have the delay time. This time it's been cut to 50 to make it faster, for a little bit of more flashier show. Once again, we have for integer, we have that if it equals 0 or it is less than or equal to 7, the variable name I, not integer, the variable name I will increase by 1, and at the same time the integer of LED will decrease by 1 for I. The integer I will determine which green LED turns on, and the integer of LED will determine which LED turns off. Essentially, as I goes up, off LED goes to the previous one down, turning the next one on and turning the one before it off. As you can see here, for LED pins, it's going to set it to high, and for the off LED, it's going to set it to low to turn it off. And of course, for the delay, it's going to be the delay time that we set on top. So that still works the same. And then lastly over here, for everything else that is not registered for the button state, if the button state is not set to high, it's going to just turn off all the LEDs. LEDs, red LED 1, red LED 2, and all of the 7 LEDs individually. Now to set it in motion, we've got the board here. There's nothing going on right now because once again, until the button state changes to high, no signal is gonna go over to the pins. But once you push the button right here, then you get the green LEDs doing once again the in and out, and you have the 2 red LEDs at a static on. And then once you let go of the button, they turn off. And to be completely honest, this was a lot of work to get it working. The green LEDs stayed the same. They're connected to the ground via their 560 ohm resistors. For the button, I had to go ahead and rewire 2 extra wires for the ground and for the 5 volt power for the 5-volt power line over to 2 different pins on the button. They're on 2 different pins. One is directly on the button, and the ground pin is connected via a 10K ohm resistor right through there. It's kind of hard to see. It's a little compact, but right through there you can see one part of the button is connected to the ground via the 10K ohm resistor. And then lastly, we have on the other side a blue wire connecting it over to digital pin number 10. And that is it for the button. That's how the button operates on power and how it connects to the pins. And then for the LEDs over here, simply we had to go ahead and once again use a different black and red wire to connect the ground and the 5-volt over to the other side of the breadboard, and then connect the 2 LEDs via their individual, that's upside down. There you go. We had to connect the 2 red LEDs by their own individual 560 ohm resistors over to the ground on this side to connect the power, and of course to make sure the LEDs don't burn out. And then right through here, right in the back, we have at the positive lead of each red, just like the green, we have them going on across over to digital pin number 11 and 12. And that's how we got those to turn on and to communicate with the rest. So yeah, that's the entirety of this board. Getting the button to work in and of itself was a lot of work, and then including the red LEDs for added difficulty was definitely challenging, but was definitely fun getting it to work. My name is Alfredo Terrazas. This is again submission for CIRC02 Attempt A, and that's everything.